Right, some spheres colliding again, all about elasticity. So I have two uniform spheres which are moving. So this one has velocity 3I plus 3J and mass 2m, and that's A. And then we've got B, which has mass 3m, and that's going negative 5I plus 2J with its velocity. Now, to really help you and the examiner, it's a good idea to do an after picture to show how you're defining your velocities. So I've got my two spheres, A and B, and there's two directions we look in when they collide, one along the line of the centres and then the line perpendicular to the centre of the spheres. So this is basically at the moment they collide, just after they collide, and what I'm going to do to help with this question is look at their velocities in two components. I'm just going to call that the velocity of A and that the velocity of B. And the reason for this is because if I split it up, then in the direction perpendicular to the centre, or the line through which the centre of the line through the centre of the sphere is, there is going to be no change in the velocity component in that direction. So that means straight away I know that that's going to be 3J and that one's going to be 2J. There's going to be no thing because it says at the instant of collision the line joining the centres is parallel to I. So perpendicular to that is the J direction, and we can straight away fill in those two components of the velocity. Right, then we need to look along the line of the centres of the mass, or the centres of the sphere. So we can look at momentum. Momentum is conserved. So in that direction, so this is the I direction, we have got 2m times 3. B, you can see, is travelling in the opposite direction in the I direction, so minus 3m times 5. And then this is where my diagram comes in helpful. So I have taken this direction to be positive. So once they have collided, I've got my A going in the opposite direction. So it's going to be negative 2m times velocity A in that direction, plus B is now travelling in the positive direction. You can simplify all that and you can get to negative 9 equals 2 velocity of A plus 3 velocity of B. We can also then look at the coefficient of restitution. So a quarter was the coefficient of restitution. Now the speed of separation is going to be the two speeds added, because they're now moving apart from each other in my diagram. Therefore, their speed of separation is both of them added. And then the speed of approach, they are also approaching each other. So it's going to be 3 plus 5. Remembering we're doing the I direction here. You can simplify that one, and you should be able to get to 2 is velocity of A plus velocity of B. And then we can solve these simultaneously, and you can get to VA is 3, VB is negative 1. That means I've now got the components I need for B, and I can answer the question. It wanted the velocity of B immediately after the collision. So the overall velocity of B is negative I, so there's one I in that direction, plus 2J, which we can work out straight away. It is worth noting, I think there's an error in the mark scheme. If you look at the mark scheme, in the first couple of lines seem to have confused A with B. So I think you should be talking about V. You don't actually need the velocity of A, but you can work it out quite easily if you wish, because we've solved that anyway. Okay, then we want to find the angle through the motion of B is deflected as a result of this collision. So we've got its initial velocity, and we've got final velocity. You can also keep this in IJ notation if you like. And this is now two vectors. I'm going to call that vector A, that vector B. And you should know that to find the angle between two vectors, we can use the formula for cos theta. And this is probably the easiest way. There are other ways you can draw diagrams and work with trigonometry, but we've got vectors, so we can just work this out. We can do the scalar product divided by the magnitude of both. And you can get that the angle is 41.63 degrees. Now, very careful here. The question said to the nearest degree. So the answer is 42 degrees.